so for this lesson, we'll be continuing on with the techniques and applications for definite integration. So for this lesson of definite integration, we have these two examples. So if you're wondering why this example is a method tool, well, you can go back to previous videos and watch the first method for this example. Well, as you can see here for this part, the example over here is, the first example is double integration d here 7y squared minus 2x dx dy, where d is bounded by y equals to x minus 2 bracket square, x is equals to 4, and over here we also have y-axis and y equals to 6. So for the previous lesson, we integrated with respect to y first, but before that, we are going to draw the graph over here. So here we have over here for this part. Okay, so first we have the y is equal to x minus 2 squared, which means that for this part, if x is like 3, that means that y will be 1 or something. So here you have to start at 2 in order for the y to start from 0. So over here, something like this. Then after that, over here for this part, we'll also have our x equals to 4. So this is the x equals to 4. Let me just and then we also have our y-axis and our y equals to 6. So for the previous few lessons, for the previous method, what we did was we separated into two parts so that we can actually integrate it. Well, for this lesson, we wouldn't need to do that because we'll be here integrated with respect to y first, compared to last lesson where I had to separate it into two parts. Okay, with the part 1 and part 2. Well, for this part over here, what you can do for this is so over here, we are integrating with respect to y first, right? And thus, if we are integrating with respect to y first, over here, you can tell that the x is from 0 to 4, while the y is from this. So the y is from x minus 2 bracket square to 6. Okay, so over here, now that we have gotten this part, what we can do is, so we can already integrate for y. So when we integrate for y, this part will have a 7 over 3. become like this instead, and then for this part, what you're going to get is, so we have the y, when you sub the 6 in, you're going to have the 6 cubed, so you'll have the 6 cubed times the 7 over 3, and then after that we'll also so over here we have a square from the start, and we also have this cube over here. So you're going to end up with it to the power of 6 dx, and dx is basically dx minus 2, and here you're going to minus so here you can integrate for this part, which you are going to get so over here you expand this part and you get and since there's another 2 here, so it's supposing you take 4 out, which you're going to get 8 for the outside. So over here you're going to get, well, for the 0 you can ignore because it's just going to be ending up with 0 anyways. But for this one you can simplify the 7s. And then when you substitute this part in, you have to minus 2. So instead of having a 4 to the power of 7, you only get 2 to the power of 7. this part you can sub it in the 0, ignore because then you only get 0, but hold on, over here for this part you can still substitute the 0 without ignoring it. And so when you substitute 0 inside, so first there's going to be a plus, then when 0 is inside, reminder that 2 it's negative 2 to the power of 7, so a negative will carry out and it will become negative once again. And this part you'll have 2 to the power of 7 over 3. And later I will combine these two, and now we can substitute this inside, while this part will just become 0 and we can ignore it. So for this, when you substitute this part inside, it will just become 6 times 4 square. And then this part you can also integrate it. So over here you can also integrate for this part. Whoops, so for this part you have an x over here, and it will become like this. Well, for this part you can leave it there, for I'll use a calculator to calculate it later on. These two you can combine, so you will be left with 2 to the power of 8 over 3. And then this part, you put it the same, later we'll use the calculator for it. And then for this part, this will become 4 to the power of 4. Well, as you can see for this part, it will become 4 to the power of 3 because there's going to be 1 4 over here. 4 to the power of 3, basically 64 times 2 over here. Then for this part, but we won't be using it for now. So for this part, what we're going to do is, for this we will also sub it in. So when we sub it in, what we're going to get will be 4 to the power of 3, so 8 times 4 to the power of 3 over 3. Then after that, over here for this part, you can simplify a 2 and you get 4 over here. And then you plus the 4 to the power of 3, while for the rest, the 0 that you sub it in, it will just end up with a 0. So now that we have gotten this part, what we can do is to use the calculator. So we have the 14 times 6 squared times 4. Then here we'll plus the 2 times. So over here we'll have the 8 times 4 over 4 cubed over 3. and we'll also have to add the 4 cube, which we will end up with a 1856. Okay, so we're going to end up with a 1856. If you compare to our previous lesson, we get the same result. So here just a quick look before we move on to the next question. Okay. Now moving on to our second example, what we have here is integral from pi over 4 to pi over 3d theta, integral from 0 to positive infinity e to the power of negative r squared r dr. So for this, okay, so for this part, what we'll have here will be, so you can integrate for this part already, while for this, you can put this part inside, which you're going to get a negative half to match this part, which you'll get e to the power of x later on, while for the this part, you can already integrate it, which you'll get this. And then for this part, what you're going to have is like this part, okay? Then now that we are gotten these two parts, we can substitute this inside already, substitute the boundaries, which we are going to get pi over 3 minus pi over 4. Then when you integrate for this part, what you're going to get is e to the power of negative r squared from positive infinity to 0. So apparently pi over 3 minus pi over 4 is pi over 12, and here for this part, if you substitute the earlier part inside, if you substitute the positive infinity inside, you get a 0 because first there's a negative behind it, and this is in the power, so this will be 1 over infinity, which will become 0. On the other hand, for this part, if you substitute the 0 inside, what you're going to get instead is a 1. So our answer is basically here. And since it's at the behind part, so there's going to be another minus, whereas the two negatives will cancel each other out into which you'll get like this. Okay, so that will be all for this example 2. So for the previous example, we mainly just did the method 2 for this part, which we have we have two methods. If you want to know the previous lesson, previous method, you can go to previous lessons and watch it. Well, over here, for our second question over here for this part, what we mainly had was just basic integration for this part. Okay, so that'll be all for this lesson. Last but not least, thank you for your watching.